Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to be just a quick example of efficiency calculations for heat engines. So what we're going to do is we're going to work the following short problem here. Here's the problem. What is the efficiency and work output of a heat engine that takes in 500 joules of energy and expels 400 joules to the environment? So when you're dealing with heat engines, the first thing you should always do is draw the schematic diagram for a heat engine. So this circle is going to represent my heat engine, and heat engines always work off of some hot source. They always expel energy to some cold source, right? And they output work. So again, we take energy from a hot source, that's usually called Q sub H. We get work out of the heat engine, and they expel some sort of energy to what's called the cold source, which is typically the environment. All right, so now that I got my picture here, I'm going to write out the following equations. 1, what comes into the heat engine, which is Q sub H, has to leave the heat engine, which is the sum of these two terms, the work term plus the Q sub C term. Now in the problem that I've kind of made up here, the Q sub H, that's the 500 joules, because that's energy that's going in. So this is going to read 500 joules equals the work term that we do not know plus the Q sub C, right? Expels 400 joules to the environment. So the Q sub C here is 400 joules in this example. So if we now solve this for the work term, we're going to get 500 joules minus 400 joules, which is 100 joules. All right, now, efficiency is output over input. So in this case, in the case of this heat engine, the work term is our output, 100 joules, over our input, which is 500 joules. So this heat engine here is running at an efficiency of 0.2, or in terms of decimals, that's 20%. Pretty typical efficiency for most heat engines. Car engines are right around 20%, maybe a tad higher, but not much. Coal power plants are, or other types of power plants, probably run in the, I'm kind of guessing 30% efficiency range, maybe a tad higher, but probably not much. The only efficiencies that I'm aware of in any heat engine that break, like go through that 50% barrier, would be nuclear power plants. There are certain power plants where the temperatures, the steam temperatures, are very, very, very high, and those run on efficiencies, I think, that are right around 50%. But 20% is a real common efficiency for a heat engine. The purposes of this video is just to come up with a nice simple example of how to write equations that describe heat engines, and this is a relatively simple one, but I think it still is successful relative to the goal of the video. So I hope that this helps demonstrate how to do that. Have a great day.